friends, I welcome you all in this session. As you are aware, in previous session we worked out couple of examples using Minitab software. In this session as well, we will continue our exercise and we will take up couple of examples not only related to hypothesis testing of proportion, but hypothesis testing of mean, and there would be one tail tests as well, right. So, let us look at this question. For a sample of 60 women taken from a population of over 5,000 enrolled in a weight reduction program at a nationwide chain of health spas, the sample mean diastolic BP is 101 and the sample standard deviation is 42, right. So, first let us look at this. N is 60, sample mean is 101 and sample standard deviation S, right. You have not been given population standard deviation, but the sample standard deviation, right, which is 42. So, by looking at this particular information, you would have understood that this is what type test. Is this a case of T test or Z test? It is a case of T test, right, because we have not been given, though the sample size is not 30 or less than 30, but still this is a case of T tail test. So, let us look at this. At a significance level of 0.02 on average, did the woman enroll in the program have diastolic blood pressure that exceeds value of 75? So, what's the hypothesis here? So, in a sample of 60, the mean blood pressure is this much and standard deviation this much at a significant level of 2% on an average. Did the woman enroll? So, the women who were enrolled in the program have diastolic BP more than 75. So, here mean is 75 and mean is more than 75. So, this is your null hypothesis and this is alternate hypothesis. With n is equal to 60, sample mean this, sample standard deviation this. So, let us work out this example. So, this is a case of an upper tail test, right, this type of test, right. So, let us look at this. We will go to stat, basic statistics, this one T test, this is one sample T test. Click over here. This is how you can enter data. So, either you can enter data in these columns over here or you can have summarized data. So, sample size is there, it was 60, sample mean 101, sample standard deviation 42, perform hypothesis test, hypothesized mean, this is important. So, is 75. Options. So, this is a case of before that we can enter confidence level. So, confidence level is 98% and alternative hypothesis mean greater than hypothesized mean, right. Let us look at answer to this question. Click OK. So, P is this 0 0 0. right. So, null hypothesis and alternative hypothesis. So, P is 0 here, right. Let us take a decision. So, P is 0, alpha is 0.02. Is P less than alpha? Yes, P is less than alpha. So, we will reject null hypothesis, reject H naught, reject null hypothesis. It means that the blood pressure exceeded 75 value. We are rejecting null hypothesis. Okay. So, we can say that over a period of time the BP has gone up, right. Let us look at one more example. The data processing department at a large life insurance has installed new color video display terminals to replace the old monochrome units it previously used to have. The 95 operators trained to use the new machines average this much hours. So, N 95 sample means 7.2 hours before achieving a satisfactory level of performance. Their sample variance, keep in mind, this is sample variance, this S square, right, is 16.2 was this much. So, sample variance was 16.2 squared hours. Long experience with operator on the old monochrome terminals showed that they averaged this much hours on machine before their performance were satisfactory, 8.1 hour. At 0.01 significance level, should the supervisor of the department conclude that the new terminals are easier to learn to operate. So, this is the sample size and this is the average time, training time, sample variance is this much, and from the past long experience the operator on old terminals showed that they average this much of hours, right. So, this is mean 8.1 and this is what we want to know, whether the department conclude that the new terminals are easier to learn, or it means does it take less time. So, this is alternative hypothesis is less than 8.1, right. So, this is a case of what type of test, T test or Z test. This is again a case of T test, right, and N is of course 95. So, let us work out this example and we will enter data. So, one sample T test. So, stat basic statistics, it is one sample T test, right. So, sample size, just enter sample size, it is 95, sample mean 7.2, and if you look at samples variance is 16.2. So, we have to enter standard deviation, so under root of this. So, let us take it 4, right, approximately 4 point something, right. So, we will enter it standard deviation as 4. Hypothesized mean would be 8.1. We will go to options and we will see what is our confidence level. So, confidence level is 99%. This is a case of upper tail test or lower tail test. This is a case of lower tail test, right. So, let us enter mean as less than hypothesized mean. So, we will click OK, and this is p value 0.015. 0.015 is the p value. So, let us look at whether we will reject or not reject null hypothesis. So, what it is 0.015, 0.015, this is p value, right. What is alpha value? 0.1. Is p less than alpha? No. So, we will not reject null hypothesis. If p is not less than alpha, we will not reject, otherwise we would have rejected it, right. So, we will not reject null hypothesis. It means we will say that the training time on old terminals and new terminals is same. There is no significant difference on training time. So, with this we have finished examples using Minitab on one sample hypothesis testing, and we have worked out several examples. We have worked out almost 15 to 20 examples. Let us move on to our next topic, which is hypothesis testing of two sample tests. So, we will have now two different samples and ANOVA, it is called analysis of variance. So, in coming slides, in coming lectures, I will be talking to you about analysis of variance. So, first let us look at what is two sample hypothesis testing. So far we have seen one sample hypothesis testing. So, in two sample tests what happens? You actually have two different independent samples, and you take samples from both the samples and you try to find out is there any difference in their population means, right. So, you can have a situation like this. You can compare their population means, you can compare their population proportions, you can compare their population variances. Now, when you compare population means, you can have two different scenarios. In first scenario, you can have just independent samples. So, there are two samples, they would be totally independent of each other, and the other scenario would be they would be dependent on each other. So, they are called related samples or dependent samples. They are also called paired samples, right. So, basically we are looking at broadly three categories: population means, proportion and variances. But when we look at population means, we can have independent samples or dependent samples, right. So, here we compare two means. Again, in when we talk about dependent samples, we will have same group before and after. So, we will collect data from one sample first, and then after some time we will collect data on the same sample, because we are saying they are it's a related sample, right. Of course, we can compare proportions and variances, right. So, difference between two means, you can have two situations: standard deviations unknown but equal, unknown but unequal. This is second case, right. This first case, this case number 1, this case number 2, right. So, they are unknown but equal, assumed equal, they are unknown but they are not equal, right. So, we want to test hypothesis, or we want to form confidence interval for the difference between two population means. So, this mean of population 1, mean of population 2, and we will do it using point estimate, right, or we will take sample, this is the sample mean of the samples you have taken from first population and this from second population, right. So, we will compare population proportions of two samples using samples from those two populations. So, as I said, you can have independent samples. The sample 1 is the population 1 is totally independent of population 2, right, or they are you can call them unrelated samples, right. So, sample selected from one population has no effect on sample selected from other population. That is the meaning of independent sample, which I have already explained. So, when you assume these two equal, right, standard deviation are unknown, but you are assuming them equal. So, there is something called we will use pooled variance test, SP. This is nothing but pooled variance. This we will use to estimate unknown standard deviations. In second case, we will use standard deviation of sample 1, standard deviation of sample 2 to estimate population standard deviations. In this case, pooled variance, and in this case, sample standard deviations. So, this is how the two sample test works. So, you can have two population means and independent samples. So, this is, let us say this is your null hypothesis, where you are saying that the mean of population 1 is greater than or equal to mean of population 2, and alternative hypothesis is it can be just, you can have only just one sign over here now, right. Its alternative hypothesis, mean of first population is greater than mean of second population, and alternatively we can write this as this like this. So, mu 1 minus mu 2 greater than or equal to 0, and alternative hypothesis can be written as mu 1 minus mu 2 less than 0, right. So, this is lower tail test. How did you come to know about lower tail test? Whether why this is a lower tail test? Because this sign of alternative hypothesis, right, which is less than type. So, this is lower tail test. Just similar to this, you will have upper tail test, right. Just see this sign. So, sign in alternative hypothesis is greater than type. So, this is an upper tail test, and of course, you can write null hypothesis like this and alternative hypothesis like this. Now, since you know what is what would be the what would be lower tail test and upper tail test. If the sign is not equal to type, it would be two tail test, similar to what we have seen in case of one sample hypothesis testing. So, this is how the distributions would look like. So, this is lower tail test or left tail test, this is your rejection region, is not it, and in upper tail test or right tail test, this is your rejection region, and in two tail test you have two rejection regions, right. So, this is one rejection region and this is second rejection region, right, and this is non-rejection region, non-rejection region. So, if the sample statistics and hypothesized population parameter are in this region, then you will not reject null hypothesis. So, let us look at this case when these two are unknown and we assume them equal, right. So, when we assume them equal, we will use pooled variance of both the populations. So, we will take sample from first population and that sample size is n1, n2 is the sample size of sample which you have taken from population 2. S1 this standard deviation of first population, standard deviation of second population, right. So, n1 and N1, N2, S1, S2, right. So, these two are variances, right. So, this is pooled variance, and the T statistics which you would be calculating is this x1 bar minus x2 bar minus. So, first sample mean minus second sample mean minus population mean, first population mean, second population mean, divided by under root of pooled variance, right. So, this SP square pooled variance and multiplied by this. So, here we have seen in case of one sample test that whenever we used T statistics, we always used degree of freedom as n minus 1, is not it. But since here you have got two samples, so the degrees of freedom would be, you just add those two samples minus 2, right. So, this is minus 2 because there are two samples, right. Now, the confidence interval for this would be x1 minus x2 plus minus T alpha by 2, this value which we have already discussed. Again T value at n minus n1 plus n2 minus 2 degrees of freedom. So, this confidence interval approach can be used, or you can use this critical value approach for testing hypothesis. So, let us look at this question, very interesting question. You are a financial analyst for a brokerage firm. Is there a difference in dividend yield between stocks listed on New York Stock Exchange and Nasdaq? You collect the following data. So, you have collected 21 stocks from New York Stock Exchange and 25 stocks from Nasdaq. You found that the sample mean is 3.27 and from Nasdaq it is 2.53. Sample standard deviation of these 21 stocks 1.3 and it is 1.16. Now, what is the question? Is there a difference in dividend yield? It means this mean. Is there any difference between mean of these two stocks, these two stock exchanges? So, 21 stocks you have taken from this stock exchange, 25 from this stock exchange, and you are comparing mean of these stocks. Assuming that both populations are approximately normal with equal variance, equal variances, is there any difference in mean yield? So, if I ask you in which stock would you like to invest, whether in New York Stock Exchange or Nasdaq, by looking at this data, you have the mean and standard deviation of couple of stocks of these two stock exchanges. So, how would you proceed? What kind of example is this? So, first of all, this is a hypothesis testing of two samples, right? And since we want to know the difference, right? Is there any difference these two? So, initially we will say that mu 1 is equal to mu 2, right. So, this is our null hypothesis H naught, and alternative hypothesis, in fact I can write this as the same as mu 1 minus mu 2 equal to 0, is not it? It is up to you how you are writing it, right. Okay. So, this is null hypothesis, and alternative hypothesis would be what? Mu 1 is not equal to mu 2. So, this is a case of what? It is a t test or z test case. So, in fact, by looking at this you would have understood that this is a two-tail test first of all, right. But what about TRZ test? Since we have been given sample standard deviation, right, and here in fact sample size in both of these is less than 30. So, in fact, we have seen a case when sample size was 60 and sample standard deviation was given. So, we applied t test. So, here we will apply t test, right. So, this is how you should write null and alternative hypothesis. This is what I have already written. Mu1 and mu2 are same, alternative hypothesis they are not same. So, t is 2.04. So, this is mean of first 21 samples, just see this 3.27 and x2 bar is 2.53, right, x2 bar, and mu1 minus mu2 is 0, because we are saying that they are same, there is no difference. Okay, so, this is mu1 minus mu2 is equal to 0, right. This is what we have said initially, right. Mu1 minus mu2 is equal to 0, right. This is pooled variance. So, first calculate this pooled variance. This n1 is what? N1 is 21, N2 is 25, right. So, 21, N2 is 25. So, 21 minus 1 and 25 minus 1, this is standard deviation, right, not standard deviation, this variance, right. S1 square is variance, right. So, this is sample standard deviation. So, you just you need to take square of this. So, you just taken square of this 1.3 square, right. This standard deviation of all the stocks of all 25 stocks of Nasdaq stock exchange, right, of course divided by N1 minus 1 plus N2 minus 1, right. So, this is pooled variance. So, before calculation of t statistics, in fact, you should calculate SP, right, and the so this is variance, right, pooled variance. So, this 1.501 which you can write over here in this formula, 1 by 21 plus 1 by 25. So, this is how you should be getting t value, calculated t value. Now what? Would you reject or you will not reject null hypothesis? Again, you should look at your t value, right. So, t value is to be looked at 44 degrees of freedom, right. So, this is 21 N1 plus N2 minus 2, 44 degrees of freedom. So, when you look at t table which is there, it says 2.01 at 44 degrees of freedom, this 44 degrees of freedom, this is 2.040, right. So, 2.040, let us look at once again at 44 degrees of freedom, 2.01, this is the one, right. So, these are your critical table values, right. So, minus 2.0154 plus 2. So, is our calculated value falling in this region? It's falling in rejection region, right. So, 2.015 and this 2.04. So, this is somewhere here, right, in rejection region. So, we will reject the null hypothesis. So, you will reject the null hypothesis and conclude that these two means are not same, they are different. The evidence is that there is a difference in mean. So, difference in mean, right, it means they are not equal. So, which has got higher mean, where would you invest, would you like to invest after looking at this result? You would like to invest in that share market where mean is higher, right. So, mean is higher where it is in New York Stock Exchange. So, you would like to invest in New York Stock Exchange. So, this is just an example on two simple hypothesis testing. In next class, we will work out couple of more examples and then we will use Minitab software to work out examples. Thank you very much.